Assalamu alaikum. This is the last part of module 1. Here we will see a very short description of what truncation error is, and we will see how error propagation happens in any type of mathematical calculations. From the definition, we can see that a truncation error occurs when an infinite mathematical process is cut short to make computation practical. To understand this phenomenon, I have given you one assignment about Taylor series. I think by now you all understand what Taylor series is. This is basically a method of uh, describing a function in the form of polynomial, and that polynomial is infinitesimal. So to understand this thing very clearly, we can take one example that e to the power x is one such function, and applying Taylor series to that, we get something like this. So this is the Taylor series version of e to the power x. Okay. So if we see, this is the Taylor version from Taylor series for e to the power x, and we are now interested in knowing the value of e to the power zero point 0.5. So to get that, we would have to put the value of x as zero point 0.5 and plug it in into the series. See, if we calculate up to the first term, the value we get for e to the power zero point 0.5 is 1. But in real, the value of e to the power zero point 0.5 is this. That means if we truncate the series after the first term, the value we are getting is definitely not equal to the value that is the actual value of e to the power zero point 0.5. That means there is an error uh, that can be visibly seen. So the difference between these two values is the amount of error here, and that is truncation error. If we let our calculation go up to the second term, in that case we get the value of e to the power zero point 0.5 as 1.5, which is also far from the exact value. So in that case, the truncation error is lower than the previous case. If we let our calculation go up to the third term, in that case also we get to see some error, but in that case the error is also in lesser amount. If we keep adding values from keep adding terms of Taylor series into while calculating this value, we will the error will get cut short as we increase the number of terms. So that is basically the idea of truncation error, and this is what happens uh, if we just look at the definition. Then we have another topic that we need to understand or study from uh, the numerical methods uh, in our course contents of module 1. This is the last topic, that is called error propagation. We have seen how we can do a mathematical calculation by doing iterations, and if we are to do some iterations applying some formula, in that case we have to start with the approximation, and after the approximation, first approximation, we do some calculation, then we get another approximate value, then we do some calculation, then we get another approximate value, and in between the two consecutive approximate values we see some errors. Now my point is, if we approximate some value which is very further away from the exact value, in that case the amount of error is higher, and in each iterations the error will get propagated as we move forward. It is just like this meme.
একটা মিথ্যা কথা বললে অনেক মিথ্যা কথা মানে অনেক একটা মিথ্যা কথা বললে
So just like that, if you keep one error in one iteration, and if you let that error go into another iteration, that means the error will get propagated as you move forward. And if the gap between the exact value and your current approximation is higher, that means the level of error is higher, and it is meant to get propagated as you move forward. This can be seen from a Google Sheet that I have attached here. If you go to the Google Sheet, I have no, I have formulated the Heron's algorithm here. So if you just apply the initial approximation and the value of the square root that you were intending to find out, you will get to see the results here. See here, if you by default here the initial approximation is 2 and the setup is done for calculating the square root of 5. So the initial approximation is 2, then the second approximation is 2.25, and in the third iteration we get 2.2361, and in this way on and on and on. Okay. Now the topic that and here in this column you can see the percentage of error. If we take our initial approximation further away from the exact value, see what happens. Let's assume zero point 0.5 for the square root of 5. What will happen? See, it takes much more iterations to get to the final result, and because why it is happening? Because it is happening because we have taken one approximate value which is very further away from the exact value. Since we have introduced a higher value of error into our system, that is why the error got propagated much further. If you take another value which is more further away from the exact value, it's a zero point 0.1, see the error got propagated much more iterations. So that is the main idea. So in our calculations, we have to be very careful that we are taking the approximate values carefully. There's another way to explain this. We'll provide some problems related to that in your numerical problem repository. So that was the total contents of module 1, and it is very unfortunate that we couldn't discuss all these things in our face-to-face classes. Hopefully, we will get the chance to discuss the further topics as we move. Thank you very much for your attention.